So can you determine what permissions you have on that file? Stick around to find out how.
You're watching IT Pro TV.
Hello, ladies and gentlemen. Thank you for tuning in to more of the LPIC 1 Linux Administrator. That's right, we're going to be talking about POSIX-based file permissions in this episode. Don, what are some of the goals?
Well, our primary goal is to learn about what the heck POSIX-based file permissions even are in the first place. Then we're going to learn about how to see them, view them, modify them, and understand what's possible to be done with those permissions, and understand a few scenarios of where we would actually make use of them.
So throughout this series, I've learned that POSIX is very hard to say for some reason, Don. How do we determine what file permissions are actually on a file?
All right. Well, remember that the Linux world is a very mature, old system. It's been around a while, but it's all based upon Unix, which is even older. It goes back 50 years now. Well, we try to maintain compatibility of applications and other systems across all these different versions of Unix and Linux and the variants that are out there to try and be somewhat compatible. And POSIX is what defines that compatibility. So if you have a POSIX compliant system, then in theory, an application that's POSIX compliant will run regardless of whether you're on Unix or Linux or Mac OS or whatever, right? So having a consistent file system with consistent permissions is important in order for an application to work. And so what we're going to learn about here are the permissions that we can set that are truly POSIX compliant that we know will maintain compatibility with old Unix stuff. Now, you might not care about any of that. You might be saying, Don, I'm not running old garbage code. I just have new cutting edge stuff. Why do I care? Well, you have to care because every file does have permissions assigned to it. And that's kind of what Wes was asking, how do we even see what's going on there? Well, if I drop to my home directory, and in my home directory, I run ls-l, that's going to give me the long listing, and I can see everything in my home folder. And everything has permissions. I see them right over here on the left side of my screen. Whoops, which I am not going to click on. So if I take a look on the left side of my screen, I'm not quite sure what's going on there. There we go. I'm trying to zoom when I'm pulling up my application launcher. I can see these permissions. Now, the very first character is actually not a permission. It's identifying whether this is a directory or a file. So notice I've got D's on most everything because they're directories, and then I've got a dash on this one. That's a script, script.sh sitting right there, so that's just a file. But after that, things start to look a lot more consistent. What you're seeing are clusters of 3 letters. RWX, 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 right? The R stands for read permissions. The W is write. Can I write or change a file? And delete falls under write as well. And then X, can I execute it? Can I run it? If it's a script or a binary, I need to be able to execute and run that application. So that's what X is. If you see a dash, that means you don't have that permission. So notice on my script down here that I've got RWX. That first one applies to the owner of the file, right? I'm the owner. I created that file. So that's they consider it the U or user, but it's also called the owner. So that's the user permission for that file. And as the user who created it, I would have read, write, and execute permissions on it. So I can read the file, I can open it and look at it, I can write it, I can change it, and then I can execute, actually run it and make it do something. Then I see the group permissions. The group permissions are the same, read, write, and execute. In my case, the group is still dpossessed, but we saw in another episode we could change that group to something else. And then lastly, I get the everybody else permissions. Everybody else can read, cannot write. They can't change it, but they can execute it. They can run my script. They can see what the script does, but they can't change the script, right? That's how these permissions are reflected right here. And in the POSIX world, these are referred to as UGO. U is the user or the owner of the file. G is the group. And O is other. Other meaning other users, other groups, other people that aren't the U or the G that's currently assigned to this one. So when I look at these columns up here, I see the U, I see the G, but I don't see a third column, which would be other, because it would just be the same thing for everybody. It would say everybody else, right? Which is what that is. So those 3 permissions, the U, G, O, those make up the POSIX compliant permissions for these files.
You know, 2 things that you said, Don, that are kind of sticking with me is old. It's been around for a while. And then the POSIX compliant side, weren't these originally or maybe used to be set with numbers?
Yes, they were. So what we're seeing here on the screen, these are symbols. Symbols that are super easy to interpret. R for read, W for write, X for execute, U for the user, G for the group, O for other. I mean, that really cut and dry. If you memorize that, you will get 9 out of 10 permission questions right on the exam. And also, you'll be able to change permissions in real life without having to Google it or pull up a man file. It's that simple. But under the hood, it's a little more complex. In the Unix world, permissions were maintained with these bit values. And you would change these bits to reflect a certain set of permissions. So for example, when I saw my script had RWX, RWX, R-X, that would actually be represented as 775. 775, 7 means read, write, and execute. 5 means read and execute. Now, how do I know that? Well, the short answer is I memorized it 20 years ago when I needed it and it was important. I memorized it and it's still stuck in my head today. But you can actually calculate it out, and there's a number of good resources that are out there. I'm going to bring up a web page. This web page is right here. It's permissions-calculator.org. And if you ever go to it, what it shows down here at the bottom are the bit values that would be calculated for a set of permissions. So for example, if I wanted the user to have read permissions, I could click the R and see how it just changed to a 4 down there? 4 is just read permissions. If I click the W, read and write becomes a 6. And then if I click the execute, it becomes a 7. So if I want read, write, and execute, the bit value would be a 7. And so if I want the group to be read, write, and execute, but I want the other to be just read and execute, there's the 775 that I rattled off a moment ago. Now, I didn't use a cool calculator for that. I just memorized it. A very common permission you'll see is 755, where the user, whoever created it, can read, write, and execute, but everybody else can just read and execute. Or maybe it's just reading that I want other people to do. Or maybe I want the other people to have nothing. I don't want them to have anything. I want the group to be able to read, but only I can write and execute. That would be a 740. Or Wes and I were talking before about like SSH keys that we might need to protect. And Wes, I think I told you the wrong number earlier. So it would be 400. The user gets read, everybody else gets nothing. That's a super lockdown file right there. And we learned about the sticky bit in another episode. So if I've gone through and set this up, let me go with the default like 755 that we're used to seeing. And I come in and I add that sticky bit to it, you'll see this extra bit changes. That's how it keeps track of it. These 4 numbers are the bit values that represent those permissions. Now, fortunately for us in today's world, really for the last decade now, you haven't had to learn these numbers. It's a possibility they could show up on the exam, but it's pretty unlikely. And in real life, it's easier to just use the symbols instead of the numbers. And so most of us just remember these, the RWX values, and we can go in and we can assign those and get them set.
So the ls command with maybe some options here will allow us to see these permissions on. How do we actually set or modify the permissions that we're seeing?
Sure. So changing them is pretty easy. In fact, we've already seen the command. Back in the ownership episode, we talked about the chmod command, which was how I assigned a sticky bit in that episode. Well, the sticky bit is just a permission. And so we use chmod to go in and change permissions, not just the sticky bit, but everything else. And all we have to remember is that UGO and RWX. And if you can remember those, you can go in and you can change permissions. So for example, let's get into my documents folder. And I've got a couple of books in here. And looking at my books, I can see that right now, I as the user have read and write. The group has read and write, and everybody else has read that's on them, okay? Well, maybe I don't want the group to have write. I want to take away the write permissions. Well, what I can do is I can say chmod, and then I can specify what I'm changing. Am I changing the user, the group, or other? I want to change group, so I'm going to say G. And then, am I adding, taking away, or overriding? If I'm adding permissions, I'll do a plus. If I'm taking away permissions, I'll do a minus. If I'm overriding the permissions, I would do an equal sign. Okay, so plus, minus, or equal. In this case, I want to take away write permissions from the group. So I'm going to say minus, and then the permission I want to take away. I'm going to take away the write permission. So G minus W. And then I'll specify the file that I want to modify. I'm going to modify dracula.txt. Okay, when I run that, I don't get any feedback, but if I do an ls-l, I can see Dracula and the write permissions are now gone from the group. It took that one away, right? This is kind of like a surgical strike. I'm just getting in and removing it. You can actually remove more than one permission at the same time or add more than one permission. Let's say I want to add execute for the user and the group, right? I could come in, these are text files, so I wouldn't normally do that, but we'll just use it as an example. So I'll come in and do chmod, or let me be a little more realistic. Maybe I'll take away read permission from the group and from the other. These guys right here, the two R's. Okay, I want to take those reads away. So I would say chmod u minus R, not u, g minus R. I'm taking away from the group, and then comma o minus R. I'm removing read from the other group as well. So you just use a comma and you specify the other things that you want, and then the file I want to modify. And I could do a wildcard here. I'm just going to do Dracula. And so when I run that, I can pull up my listing, and now I see those read permissions are gone, okay? Now, let's say that I wanted to give read, write, execute to everybody. Okay, well, I could write this out a few different ways. I could look at it and say, okay, well, I've only got read and write, so I might need to say chmod u plus x, and then group doesn't have anything, so I could say g plus rwx, and then o plus RWX, like that, kind of writing it all out. And when you do that, it works, right? This is the right syntax. It's just really long. And so sometimes it's easier to override by combining things together. You've seen me combine permissions, right? So I could say chmod g plus rw Dracula.txt like that. So I just added read and write at the same time by sticking them together. You can do the same thing with UGO. So I could say chmod UGO equals RW. By doing equal, I'm overwriting. It's going to wipe out whatever permissions are there, and it's going to change it to be RW, and I can specify that on Dracula. And so now everyone should have read and write. I just hard set those permissions. I didn't care what was already set there. So really easy way to do that, and way shorter than typing it out and setting each one individually. So these symbols, super handy, super convenient.
So Don, let's talk defaults. Where are these default permissions coming from? We've seen that before, like when you create a file or a folder, we get a default owner. Where are these coming from?
All right, so if you've got a folder created and you create a file inside of it, it's actually inheriting permissions from the folder. But where did the folder get its permissions from? Well, maybe it's inheriting, right? But at some point, the permissions had to come from somewhere. And so deep down in the system, if you dig around, you can actually find where your Linux distro is setting those default permissions. Unfortunately, it's difficult to track because different distros set them to different values, and they can be overridden left and right all over the place. So for example, home directories, there's a service called systemd homed that it actually defines what those permissions would be on that folder. And there's other systems that are related to creating home directories that can override those values. So it can be a little bit tricky. But if you want to find the actual root of all of this, there's two places that you want to look. So one place is if you want to look inside of /etc, there's a file in /etc that's called profile. And I thought it would be at the bottom, but it's not. Here it is up at the top. Here's profile. Okay, and if we take a look at that, so I'm going to do a less/etc/profile, and if you poke around there, you'll see a lot of really crazy things. And what you may find is somewhere in here, you may find what's called a umask. And the umask is actually what's defining the default file permissions that end up on your hard drive. Now, in my case, I don't see one. And I likely don't see it because of this line down here that's telling me that it's loading a folder, everything inside of /etc/profile.d/star. So now I'd have to go and dig around in there. So let me look at that. And there's a bunch of files in here. So I guess we can grep it. So I'm going to look for umask in this folder. And it didn't find it. It may not actually be set then. It may be going with the default of the kernel. So it's not always set. Remember I said it's difficult sometimes as you move between distros. So your umask may be specifically defined in here, or it might not. It can also be overridden inside of your home folder. So if I go back to my home folder and I do an ls-la, you'll have a .bashrc file. And that's your bash configuration. And the umask can be overridden inside of bashrc as well. Let's see if mine is. and it likely isn't because I haven't modified it, but let's just take a look and see. So if you poke around in here, you may actually find a UMask value set. And I just realized when I grepped for it earlier, I grepped all lowercase, and it's probably uppercase. And so I'm not finding it here. Let's just look for UMask or UMask. And yeah, so it's not overridden. But it can be set in here. Be careful with the UMask file, though, because what you'll see basically is an entry that just says UMask followed by 4 numbers. And those 4 numbers conform to the permissions that we saw, like in the bit calculator on the screen earlier. It conforms to that. But UMask values are actually written in the opposite bit value, which is really confusing because I just showed you where a 7 meant you had read, write, and execute. But in a UMask, it's the opposite. So a 7 means you have nothing. And in regular permissions, a 0 would mean you have nothing, but in UMask, a 0 means you have everything. It means you have read, write, and execute, right? So that's kind of the way that it defines it. And so it's a strange number. If you're going to modify it, you need to pull up the man pages for UMask, make sure you get the right values and get that put in place, because otherwise it's really a difficult thing to get in and set.
So Don, can you think of a scenario where maybe you might change those default masks, or default, I should say, numerical values?
All right. I will tell you that throughout my entire Linux career, which stems back to the 1990s, I change file permissions all the time, tons of times. I use the sticky bit when I need it. Like, those are all tools in my toolbox that I use to make sure I have the permission structure that I want, especially when working with NFS servers. When you've got network shares, those permissions become super important. But in my entire career, not once have I ever needed to change the UMask value. And I actively avoid it, because if you manipulate the default behavior of a system and somebody new comes to administer the system, now they're not going to know what those default permissions are. It creates unusual behavior. And worse, it can lead to security exploits. You're increasing your attack surface if you set default permissions that are inaccurate, and then it applies to folders that may be giving an attacker more access than necessary. So in real life land, it's not something we change. And on the exam objectives, they even call it out as something that you need to be able to describe, not necessarily do. So I want you to be aware of it, that the UMask is where those defaults come from, but it's not something you really have to manipulate. And you can override permissions at any point just by using the chmod command, and then you change the permissions the way you need it. That's a better way to go about it, because that's easy to see where those came from, and it's easy to change if you need to.
All right, POSIX-based file permissions. Don, what are some of the key takeaways for our viewers in this episode?
All right, so we learned about the owner objects. Well, the various objects that are in control of a file. U for user or owner, G for group, and O for other. We also learned about the permissions themselves, read, write, and execute, and how they're defined. We talked a little bit about the bit values that Unix used to use to keep track of that, but we saw how with the chmod command, we could use the numbers if we wanted to, if we were a glutton for punishment, or we could use the new symbol architecture to be able to structure that out in a way that makes super easy sense that can go in and override. We also learned about plus for adding permissions, minus for removing, and equal for overriding to be able to set those. And lastly, we talked about UMask and where those default permissions come from.
All right, ladies and gentlemen, a lot of great information in this episode. But speaking of great information, we got a lot more exciting content coming up in the LPIC 1 Linux Administrator, so stay tuned.
Thank you for watching IT Pro TV.